So let's look at this example then, which is in the text if you wanted to find it. If you look at combining angles, I think it's called, something like that, or the compound, no, it's not the compound angle formula, but it's around there. If you look at it, I can't exactly know what it's called, you'll see this problem in there, and they'll set out how they found it out, but it might be slightly different to this, so it might be worth looking at both. So we've got our two formula to find r and phi, and we're given these two waves, 3 sine omega t, 4 cos omega t. So if we look back to the slide here, then A is the number in front of the sine part of the formula, and B is the number in front of the cosine. So looking at our problem here, we can say that A is 3 and B is 4. And then we can use Pythagoras and that 10 to the minus 1 to work out what they are. So I'll just pause this while you work out what r and phi are. So calculating it, r turns out to be 5, 3, 4, 5 triangle, and the angle phi turns out to be 0.93 radians if we measure to two significant figures. So there's our values for phi and r. So what we're saying is that 3 sine omega t plus 4 cos omega t equals 5 sine omega t plus 0.93. That's what we're saying, that they are the same. So what we can do now is we can prove that this is true. Is that true? So what I can do in Autograph is to start a new page and type into Autograph the first part of our expression. Y equals 3 sine omega x plus 4 cos omega x. So I literally type in y equals 3 sine omega x, or wx, it doesn't matter what w is, so long as it's the same, plus 4 cos wx. Okay, and this is those two waves combined together. So let me just zoom out a bit so we can see it. There it is. And what we're saying is, if I now type in y equals 5 sine omega x plus 0.93, they should be equal, and they should therefore lie on top of each other on Autograph. So if I add another equation to here and type in y equals 5 sine brackets omega x plus 0.93, it might not if I'm not in radians. Am I in degrees or radians? I'll check in a sec. Hit OK. Oh, I missed out the bracket. Close bracket. OK. And they map on top of each other. And that's luckily because I was in radians. So if it doesn't work, it's because you're not in radians. And so how do I check that? Here we go. Yeah. So I could have been in degrees, in which case it wouldn't have mapped. But I happened to be in radians. And those wave functions map directly on top of each other, so we know that that must be true. If I combine these two waves, I get 5 sine omega x plus this phase difference.